Okay, this is the last video on exercise set for question 12. On question 12, it asks us this, it says, suppose that we are giving the following 6 random numbers ranked from smallest to largest, and the values are given. Notice that B is in between certain values, how it's unknown. Identify the set of p-values for which the Kolmogorov-Smirnov test rejects the uniformity of the sequence under significance level alpha equals 0.10. Now, we will be tabularizing the Kolmogorov-Smirnov test. So I connected my iPad and draw the solution of this question. This question exercise that for question 12. Okay. Now for, okay, what's the sample size there? It's, so we have 6 numbers, right? 6 random numbers. So we can say that our n begin is 6. Now we are constructing the table. It's first we put I here, 1, 2, 3, 5, and 6. Because we will be having 6 random numbers. Okay, so as you remember from the previous videos or the lecture videos, we are ordering this in an ascending way, so they will be increasing. Starting from the smallest value, from the numbers given in the question 12, we are writing the values. So this is B because it says that B is in between 0.1029 and 0.8676. So, but it is unknown. So since it is between those values, we vote like this. Okay. Back to our solution. Okay, now we wrote this in an increasing order for I. So it has the parentheses, as I mentioned before. It is the ordered sequence. So we will be computing this I over n values, which I is coming from these values, 1 to 6, and n is 6. So if you divide 1 by 6, 2 divided by 6, 3, 4, 5, goes on like this. So it's obviously ends with 1. Okay, let's write these values. Oh, I could do this in Excel, but never mind. Okay. Now, on the table, we will be writing down, as we did before, the theoretical upper and lower bound. So this value minus this value, because both of them are for I equals 1. So we will be subtracting Ri from this I over n value. 0.0. Okay. I wish I did that on Excel. Okay. You can see here. Sorry. Oh, so we have B on the Ri column for I equals 3. So we are writing like this, 0.5 minus B. So we don't know the B value. So now we will be writing I minus 1 and values, which is, so if you can see here on the first situation, when I is equal to 1, 1 minus 1 is 0, so it's obvious it's 0. And for the second iteration, is this. For I equals 3, it's this. 0.5. Okay. For the theoretical lower bound, we are subtracting I minus 1 divided by n from Ri. So again, here we do not know the B value. So writing like this, because we are subtracting the I minus 1 from n value from Ri. Okay. So here we found these values. Okay, we can say like here is theoretical upper bound, theoretical lower. Yeah, this looks so bad. Oh man. Okay. Now, out of these values, we will be finding most positive value. So we're not looking for the absolute here. Okay. So we don't know the B minus 0 point dot 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 values and this here, right? So out of the maximum here, which is 0.2204 and 0.5 minus B, we will be finding the maximum out of this, and that will be our D plus. Okay, let me write it like this. Okay. So our test statistic is the maximum out of these two values. Let me write that also. Test statistic, which is D, is the maximum out of this, the value I found for the theoretical lower bound, and okay. So since 0.3676 whatever is larger than 0.2304, I'm not writing that into this parenthesis, right? Because this value is already bigger than this. Okay, the other value with the unknown was, what was it? This. So our aim is to find the maximum out of these three components. And the critical value is, okay, our significance level is 0.10. When I check the table and find the degree of freedom of sex, we see that our critical value is 0.470. Okay, for the smallest possible value, B, we can say that okay. Here it means that for the smallest possible value, when you look at the here, this column, this here, theoretical lower bound column is the smallest one is 0.1290, right? Okay, and this subtraction does not exceed the critical value. Our critical value is 0.470. Okay. For B minus 0.333, greater than 0.470, the test rejects uniformity, right? So if B is greater than 8,033, okay, as we did in the sixth question, we said that if this our test statistic, if D is greater than our critical value, D alpha, we reject null hypothesis. If not, if it's smaller or less than or equal to D alpha, we fail to reject the null hypothesis. So if you fail to reject the null hypothesis, it means that there is a chance that the sample may come from the standard uniform distribution. Okay. If, okay, let me write that also. if So a big mistake I did here is that I didn't write the null hypothesis and the alternative hypothesis at the beginning of the question. You have to write the null hypothesis and the alternative hypothesis at the beginning. So with relation to the question, depending on the question, you have to decide what's the null hypothesis and what's the alternative hypothesis. Fail to reject the null hypothesis. Okay, let's write them then. But okay, should be I'm sorry. Okay, I don't actually need that. So I'm sorry, we are writing the null hypothesis and alternative hypothesis. You can write it like this or HA. Okay. So it says that the sample follows standard uniform distribution. And this is otherwise. Okay, wait a minute. So the test either rejects null hypothesis or fails to reject null hypothesis. So if you reject null hypothesis, you prove that alternative is correct, and failure to reject null hypothesis means there's no evidence of non-uniformity. So, okay. Let me go back. Where were we? Okay. So if B is greater than 0.8023, the test rejects the uniformity. Because in this case, when I say that, what is this? It is this and this. So we in here, if D is greater than D alpha, we reject the null hypothesis. Okay. So this is our condition. First condition for test rejecting the uniformity. And the other one was, what was it? Okay, so we found so where does the test reject uniformity? We have to write the interval, right? So our interval is, so if we say if what am I doing even? Okay, this comes from here, right? Okay. So in this interval, the test rejects uniformity. If you do not understand anything, please come to my office, or you can send a mail. Rejects uniformity. So we reject uniformity in this interval, so we can assume that the given sequence to be uniformly distributed in the unit interval. Okay, I think that's it. Again, if you have any questions, please ask via mail or come to the office. Sorry. I was recording this.